So here in this video, we'll learn how to convert binary to decimal and decimal to binary. But this thing we'll do in 3 phases. In phase number 1, we'll convert normal binary to decimal and decimal to binary. In phase number 2, we'll convert a fractional binary to decimal and a fractional decimal to binary. And in phase number 3, that is really important. In that, we'll convert a negative number to binary and a negative binary to decimal. So these are the important things that we are going to cover in this video. This thing is really important for any competitive exam point of view or your normal exam point of view. So do not forget to watch this video till the end, because this will going to help you a lot. So without wasting time, let's get started. In our previous video, we have seen that in decimal we have 10 distinct numbers 0 to 9. And in binary we have only 2 distinct numbers. So binary 0 represents decimal 0, binary 1 represents decimal 1. But in binary we have only 2 distinct digits, and if you want to represent any decimal number in binary, then you must use the combination of 1 and 0 to represent that number. So now we are going to explore how to convert binary number into decimal number. Let's suppose we have this binary number 10110 and we want to convert this binary to decimal. So first of all, just write this number in this manner, and you should know that the binary number is a weighted number system. That means each of the place has some specific weight. So first step is to write the specific weight of each number, and it is like this. So you should start from the right hand side, 2 raised to 0, 2 raised to 1, 2 raised to 2, 3, 4 and so on. So in first step you should mention the weightage of each number. The next step is to multiply that weightage with that binary number. Here 2 raised to 4 means 16, so 16 multiplied by 1. 2 raised to 3 means 8, 8 multiplied by 0, that is 0. 2 raised to 2, that is 4, 4 multiplied with 1. 2 raised to 1, it's 2, 2 multiplied with 1. And 2 raised to 0 is 0, 0 multiplied with 0. So you need to multiply each of the digit with the appropriate weightage and then add all these things together to get the decimal equivalent. So 1642 gives us 22. So the decimal equivalent of this binary number is 22. It's time for you to try whether you have learned it properly or not. So here I am giving this task 100100. You need to convert this binary number into decimal, and then do not forget to write the answer in comments below so that I can check whether you have learned it correctly or not, right? So now we are jumping towards the second method, and here we are going to convert the fractional binary into decimal. In order to convert this fractional binary to decimal, you need to split this entire number into 2 parts. One part is left hand side of the point and the another one is right hand side of the point. So let's start with the left hand side from the point. You need to write the binary numbers and give appropriate weightage to that number, and then multiply it with the number, and then you will get the answer as 22. So this section we have just calculated, and now it's time for the section of right hand side from the point. So point 101 will be calculated separately. What you supposed to do? Again the same thing, you need to write this 101 in this manner and then multiply it with the proper weightage. When you move right hand side from the point, the first point is this, and the weightage of that is 2 raised to minus 1. The second is 0 and the weightage is 2 raised to minus 2, and the third is this one and the weightage is 2 raised to minus 3. So if you multiply it with the weightage, what you will get? You will get 0.5, 0 and 0.125. The next step, just add these things together and you will get 0.625. So the decimal equivalent of 0.101 is 0.625. And now you have solved both the sections, left hand side and right hand side. So just add these things together. So 10110.101 gives 22.625. So this is the decimal equivalent to this binary number. And now we are going to jump to the task for you. This is the number that you have to solve by yourself and write the answer in comments below, and then I'll verify whether it is appropriate or not. So after this we are going to solve decimal to binary. How to convert a decimal number to binary? For that, let's suppose we have this number 115 and we are going to convert it into the binary. To convert it in binary, we have two methods. The first method is subtraction method and the second method is successive division. So we'll start with the method number 1, subtraction method. So here we want to convert this 115 into binary. So what we'll do, you're supposed to write a weighted number series like this: 2 raised to 0, 2 raised to 1, 2, 3, 4, 5, 6, 7. But up to what number you're supposed to write? Up to the number which is larger than this, you're supposed to write this series. So here you can see 128 is larger than 115, so you should write it up to 128. So 2 raised to 0 is 1, then 2, then 4, 8, 16, 32, 64 and 128. So this is the number series. Now in next step what you're supposed to do, you're supposed to find the largest number from this series which is less than 115. Here you can see this 64 is the largest number below 115. So we should subtract 64 from 115 and we'll get 51. So here we are using 64, so we should write 1 below 64. Understand this thing properly. When we are using this 64, we should write 1 below 64. Now here we get 51. So again we need to do the same thing. Largest number in this series which is below 51, that largest number is 32. So we should subtract 32 from 51 and then we'll get 19. So here in this series we are again using 32, so we'll write 1 below 32. Now again the same thing, what will be the largest number below 19? Here it is 16. So again subtract 16 from 19, the number is 13. Here we are using 16, so we should write 1 over here. Okay, so next is 3. The largest number below 3 is 2. So here below 3 the largest number is 2. So when we subtract 2 from the 3 we get 1. So here we are using 2, so we're supposed to write 1 below 2. But you can see here that after 16 we are directly jumped to 2. We are not using 8, we are not using 4. So below 8 we should write 0, below 4 we should write 0 and below 2 we should write 1. Whatever number we are using here we should write 1 below it, and whatever number we are not using we should write 0 below it. So here 2 is subtracted from 3, so we get 1, and in the next step the largest number below this 1 is 1, so we are going to use this 1. So 1 minus 1 is 0, so here we are writing 1 below the 1. So in this subtraction manner you should start with your number and reaches up to 0. Once you reach to 0 you should stop there, and when you add all this number the equal of that will be equal to 115, your number. So what will be the binary equivalent to this? This number is the binary equivalent to this decimal number. So write it from this side, 1110011. This will be the binary equivalent to this 115 decimal. So this is one of the simplest method to convert decimal to binary. And the next is 108. So now you supposed to solve this example and write the answer in comments below. Until now, if you are enjoying this video, do not forget to like this video and give your suggestion into the comment box. So solve this quickly and write in comments below, and now we are moving forward. Now we are going to solve the same numerical with the next method, and that is successive division method. To solve the same thing with successive division method, we should take 115 and then divide it by 2. So when we divide this 115 by 2, so 57 2s are 114. So subtract 114 from 115, the remainder is 1. Now again divide this 57 by 2, we'll get 28 2s are 56. So subtract this 56 from 57, again remainder is 1. Now again divide this 28 by 2, so 14 2s are 28, 28 minus 28, remainder is 0. Now again divide it by 2, so 7 2s are 14, 14 minus 14, that gives 0. So remainder is 0. Again divided it by 2, so 3 2s are 6, 6 minus 7, remainder is 1. Divided it by 2, 2 1s are 2, 2 minus 3, remainder is 1. And now you cannot further divide this 1 by 2. So we'll take this one here. So what will be the binary equivalent to this 115? You should write from bottom to top 1110011. So this will be the binary equivalent to this decimal number 115. If you have any doubt and query in this method, then do not forget to write in comments below, okay? And now in the next method, we are going to convert this fractional number into binary. Now when we want to convert a fractional number to binary, again we supposed to split it in two parts. One part is left hand side from the point and the one is on right hand side from the point. So if we talk about the left hand side part, that is 115, and the right hand side part is 0.85. So first we solve for this 115. We have just calculated about 115 and the answer we got is 1110011. So the binary conversion of 115 is like this. And now it's time for the right hand side part, 0.85. For left hand side you need to divide the number by 2, and for the right hand side, for the fractional number, you need to multiply it by 2. So 0.85 need to be multiplied with 2, so it gives us 1.7. So before point there is 1, so you should write 1 over here. So just simply understand that you are taking away 1 from this 1.7. So what will be remained? It is 0.7. So in the next step you need to multiply 0.7 with 2. It is 1.4. Again take 1 from here, right? So 0.4 is remained. So when you multiply 0.4 into 2, it gives us 0.8. When you take 0 from 0.8, only 0.8 remains. So again write 0 here and multiply 0.8 with 2. It gives us 1.6. So take 1, and in this manner you should proceed. So in fractional number you should move up to the point where you reach to 0. But most of the time it will happen that you will never reach to 0. So up to what point you should keep on repeating this process. So normal tendency is up to 3 to 4 point you should proceed and then you should stop. So here we will never reach to 0. So what we'll do, we'll calculate it for 4 points and then we'll stop. So from top to bottom, if we write it here, we'll get 1101. So this will be the binary equivalent to this decimal fractional number 0.85. So now we have left hand side part, we have right hand side part, and when we club this together we'll get the final answer 115.85. The equivalent decimal is this. So this is very simple. And now it's time to go for the negative number. How to convert a negative decimal number into binary number. For example, we have -6 and now you're supposed to convert -6 into binary. So when you want to convert a minus number to a binary number, the first step is you should convert binary equivalent to that of positive number. So first we'll convert a positive 6 binary equivalent. And for that we'll write this number series and then convert this positive 6 into binary. The binary of 6 is 110. So this 110 is binary equivalent to positive 6. Here we are representing this 110 in a 3-bit format. Generally we represent it in 4-bit, 8-bit, 16-bit, 32-bit format, right? So if we convert this number into 8-bit format, we can write it like this 110, and the rest remaining bit will add zeros. So 000000110. This is 8-bit representation of positive 6 number. But the question is, right now why we are dealing with this 4-bit and 8-bit of combinations? Let me explain you this thing with one example. For example, we have this number 100110001. So this bit is the least significant digit of this number. This digit is the most significant digit of this number. This number also indicates the sign bit. That means the value of this number, if it is 1, it represents that this number is negative number, or if it is 0, it represents that this number is a positive number. So to identification whether the number is positive or negative, this MSD is being used. Now using this concept, we are going to convert this binary positive 6 into the binary equivalent to this negative 6. There are some set of rules to convert this positive 6 into negative, and these rules are: first you should convert 1's complement of this number, and then you should take 2's complement of this number. If you don't know what is 1's complement and 2's complement, I have prepared a separate video for that. You can watch that and clear concept about that thing. The link will be in description and here in card. And now we are going to solve this number. So first of all, we'll represent this 110 into a 4-bit format. Here the first bit is 0. 0 represents it is a positive number, so we are writing a positive 6 in binary. Now the first step is convert it into the 1's complement. So we are going to take 1's complement of this number. Now how to take 1's complement? The simple is write complement of this number. The complement of 0 is 1 and the complement of 1 is 0. So 1 0 0 1. This is the 1's complement of our above number. What is the next thing? Next thing is to convert it into 2's complement. So in order to convert it into 2's complement, we should add 1 over here. This is the method how we get a 2's complement. So we'll add this 1 into this number. So 1 plus 1, it is basically 1 plus 1 is 2. In binary 1 plus 1 is 1 0, because binary equivalent of 2 is 1 0. So 0 and 1. So 1 plus 1, 0 over here, and this remaining 1 will come as a carry over here. Now again here there is no other number, so 1 plus 0, that is 1. Here there is no number, so 0 plus nothing, so 0 plus 0, that is 0. And again 1 plus nothing, so it is 1. So 1 0 1 0, it is the binary equivalent to negative 6. So minus 6 is converted into binary as 1010. But now the question is whether it is true or not. We want to verify. So we'll verify it whether it is right or wrong. So what we'll do, we'll convert this binary into decimal, and if we get minus 6, then it is correct. So how to convert binary to decimal? First we'll write the number series, and then we'll write this 1010 over here, and then we'll multiply this weight with the binary number. But here we should consider this thing, that it is the most significant digit and it is 1. When the most significant digit is 1, it represents a negative number. So when you multiply this 8 with 1, you should remember that it is minus 8. So it gives a minus 8. 4 multiplied with 0 gives us 0. 2 multiplied with 1 gives us 2, and 1 multiplied with 0 gives us 0. So now what we supposed to do? We should add all these things together. So minus 8 plus 2 gives us minus 6. So this is true that 1010 is the binary equivalent of negative 6. Now you supposed to convert this minus 81 into binary and then write the answer in comments below, so that I can verify have you learned it properly or not. In this video we have learned binary to decimal and decimal to binary conversion. Now we are going to learn binary to octal and binary to hexadecimal conversion. And for that you should watch these videos where we are going to convert these numbers. If you like this video, do not forget to hit the like button and comment me your response in comment box.